In this section, we will focus on the basic steps used for isolation fault testing in a battery electric vehicle using an insulation meter. This is a brief overview of how an insulation meter is used to conduct isolation fault testing. Step 1. Refer to the manufacturer's service manual. Step 2. Use a diagnostic scan tool to verify the affected circuit. Step 3. Use an insulation meter to test the voltage. Step 4. Plug the probes into positive and negative ports. Step 5. Ensure the insulation meter reads 550 mega-ohms. Step 6. Connect the test leads to view continuity. Step 7. Attach the alligator clamp to the tip of the negative probe when needed. Step 8. While testing inside the vehicle, use the metal bracket as a ground. Step 9. Test each lead on the stator winding. Step 10. Return the vehicle to operational status. Let us now look at these steps in detail. Step 1. Always refer to your manufacturer's service manual before you begin the isolation fault test, as the procedure could vary depending on the make and model of the vehicle. Referring to the manufacturer's guide will ensure you are following the recommended safety protocols and accurate testing procedures. Step 2. A diagnostic scan tool will be used to verify the affected circuit to test for isolation fault testing. When the circuit has been identified, the high-voltage battery may need to be de-energized or powered down before testing the affected circuit or component. Many BEVs' HV systems are de-energized using only a scan tool. Some BEVs are de-energized by disconnecting the manual service disconnect, MSD. Refer to your vehicle manufacturer's service manual for the de-energizing procedure, as it may differ among manufacturers. Step 3. Choose an insulation meter capable of testing at a minimum of 500 volts. Before use, ensure that you read all instructions and warnings for your insulation meter. The available test ranges for this meter are 50, 100, 250, 500, and 1000 volts. Choose the range button for your meter to display 500 volts. Step 4. Plug the two probes into the correct positive and negative ports. Step 5. With the test leads not connected, press and hold the test button to view how your meter displays an infinite measurement. The meter will display 550 mega-ohms when measuring an open circuit while set to the 500-volt range. Step 6. Perform a continuity test by connecting the test leads. With the test leads connected, hold either test button. The meter displays 0.0 ohms, an uninterrupted circuit known as continuity. Step 7. You need a good ground reference to perform the isolation fault test. Use an alligator clamp when needed to attach the ground test lead. Typically, the reference point will be to a vehicle chassis. Step 8. Ensure you verify the ground connection before every test measurement at a suitable ground location near your test point. As an example, we will use a metal bracket as a ground while testing inside the vehicle. When testing any high-voltage component with large capacitance or inductance, such as specific modules and large motor stators, it may be necessary to hold the test button for a few seconds, a minimum of 3 seconds, until the maximum resistance value is displayed. The meter should display 0.0 ohms, indicating continuity. Here, the device under test, DUT, is a high-voltage 3-phase electric traction motor. Two principal parts of a high-voltage traction motor are the rotor and the stator. The stator is stationary in the motor housing. The inverter switches the polarity of the electromagnetic field, so the rotor begins to rotate within the stator. Note that the stator is not easily accessible in most cases without some disassembly. In some instances, the inverter must be removed to access the motor. Some diagnostic routines may have the stator tested from the 3-wire connection at the top of the inverter. As an example, for the purpose of this lesson, we will test the traction motor stator connector. The connector needs to be disconnected to disconnect the traction motor stator connector. Step 9. Use your insulation meter to test each lead. By performing this action, you add high voltage and low current from the positive test lead to the stator winding and attach the negative test lead to the motor housing or available chassis component. Hold either test button for 3 seconds to test the first lead. The meter readings should be infinite. As an example, in this lesson, the meter reading is displayed as 550 mega-ohms. As displayed on your screen, this process must be repeated for all connections, U, V, and W. Step 10. When your testing is completed, determine the action needed. When all the repairs have been completed, return the vehicle to the operational status. Some vehicle manufacturers may replace a defective stator, while others may require the motor to be renewed. Always check your specific vehicle manufacturer's manual for the correct procedures, as procedures differ among vehicle make, model, and manufacturer. Let us recap what we have covered in the 10 steps on how to use an insulation meter to conduct isolation fault testing. Step 1. Refer to the manufacturer's service manual. Step 2. Use a diagnostic scan tool to verify the affected circuit. Step 3. Use an insulation meter to test the voltage. Step 4. Plug the probes into positive and negative ports. Step 5. Ensure the insulation meter reads 550 mega-ohms. Step 6. Connect the test leads to view continuity. Step 7. Attach the alligator clamp to the tip of the negative probe when needed. Step 8. While testing inside the vehicle, use the metal bracket as a ground. Step 9. Test each lead on the stator winding. Step 10. Return the vehicle to operational status.